Hello students, welcome back to this lecture series of M.Sc. Part 1 Physics, Mathematical Methods in Physics. In the last class we discussed about the Bessel functions of the first kind. In this lecture we are going to discuss Bessel function of the second kind of order n. Okay. So we know the very well Bessel equations, that is x square d square y by dx square plus x dy by dx plus x square minus n square into y is equal to 0. This is a Bessel differential equations. From the case third, if this n is equal to integer, then we assume the solution, that is y is equal to u is a function of yn is equal to u is a function of x into jn is a function of x. Okay. This we are going to assume the solution of this Bessel differential equations. Okay. From the second case, if n is a positive integer, okay, or it is n is a integer. Okay. So this is a y, and this dy by dx, that is a y primes. If we try to find from this y, so it is u prime jn plus u jn primes. Okay, this differentiate with respect to x because this u is a function of x and j in Bessel functions, this is also the function of x. Okay, so we can differentiate like this. And again for this case, d square y by dx square, if I again differentiate this y primes with the with respect to the x, so it is y double primes, and this thing is u double primes into jn plus u prime jn prime plus u prime jn prime plus u prime jn double primes. Okay, so this thing is the same, so we can write y double prime is equal to u prime jn u prime into jn plus 2 u prime into jn. Okay, this u prime and jn primes. Okay, 2 u prime into jn primes, and the plus u prime into jn double primes. Okay, this is the y double primes, y prime and the y. Okay, so just replace this d square y by dx square with this y double primes, and dy by dx with this y prime, and this y with this y. Okay, so this differential equation become x square into, just I am putting this y primes for this d square y by dx square, so it is u double prime into jn plus 2 u prime into jn prime plus u prime into jn prime. Okay. This is for the first term. Now plus x into dy by dx, so that is y prime, so it is u prime into jn plus u into jn prime, and last term, that is plus x square minus n square into y, so y is equal to u into jn, okay, is equal to 0. Okay, so this is the Bessel equations. In the term of the j, what we assume in the solution, that is u into jn. Okay, this u is one function and this jn is also functions. So let take out the commons, that is u from this differential equations. Okay, so if I take out the common u into, so okay, something here is a u prime to jn primes, and this is u into jn primes. Okay, so here is a only u into jn primes, right? If we differentiate these things, so we get the only this one, okay, u primes into jn prime plus u into jn double primes. Okay, so here this one. So x square into jn primes, okay, this u is take out the commons from this first terms, plus the next term, that is x into jn prime, and plus from the third terms is as it is, so x square minus n square into jn plus, now as it is all things. Okay, so plus x square u prime jn plus x square to x square u prime jn prime plus x into u prime jn, and this is equal to 0. Okay, so this is the expression we have now. If we compare these equations with the Bessel differential equation, so it is same things, and the solutions, we know the solutions, or this is the solutions of the Bessel differential equation for this thing. Okay, so this x square jn primes plus x jn primes, so x jn double prime plus x jn prime plus x square minus n square into jn is equal to 0. Okay, so this is a Bessel differential equations, and this jn is a solution of these things. Okay, so this is equal to 0, these things, and we have the now. Okay, so if this thing is equal to 0, so we can write x square u double prime into jn plus 2x square u prime into jn primes plus x u prime jn is equal to 0. So for this equation, just divide with the x square into jn into u primes. Okay, so divide to these equations with the x square into jn into u primes. Okay, so if I divide to this equation, so it is like this, u primes divided by u double prime divided by u primes plus 2, so it is x square will be cancel u prime, and so this is jn prime divided by jn plus this 1 by x is equal to 0. Okay, this is we have the expression for the Bessel differential equations for this case. Okay, n is a integer, so we can write these things in this form also, d by dx. Okay, here I am using this differentiate with respect to the x, because u is a function of x and jn is also function of x. Okay, so that's why I am taking this d by dx into log u primes plus, here it's, okay, 2 log jn plus log x is equal to 0. Okay, so if I take out the commons, log, so it is like this, d by dx log into u primes into jn square into x is equal to 0. Okay, now if I integrate these things, so it is log, integrate with respect to the x, so it is log into u primes into jn square to x is equal to c1, log c1. okay, and this c1 will be log will be cancelled, so it is u prime into jn square into x is equal to c1, and this u prime is equal to c1 divided by jn square into x. Okay, this is expression for the u1 u primes. Okay, but we assume the solutions, that is yn is equal to u into jnx. Okay, so we want here u, okay, not u prime. So again, if I integrate these things, so we can find the u. Okay, so this expressions, if I integrate, so it is u primes dx is equal to c1 jn square into x dx. Okay, so this is u is equal to integration c1 divided by jn square into x dx plus c2. Okay, so this is, we have the expression for the u. Okay, so if I put this expression into the solutions, what we are assuming, that is yn is equal to u the function of x into jn the function of x. So this u we can write, sorry, these things. Okay, so it is integrations c1 divided by jn square into x dx plus c2 and this jnx. Okay, so if I multiply with the jnx, so it is c2 jnx plus integrations c1 divided by jn square into x you can take out the common, that is jnx into c1. Okay, these things, and integrations over dx, integrations dx by jn square into x. Okay, so we can write this u or this yn, this is the solutions of the Bessel differential equation for the second kind of order n. Okay, so yn is equal to so it is writing yx is equal to u of x and jn x. Okay, and this is equal to c2 jn x plus cn x into c1 integration dx by jn square into x. Okay, so this is y2. Okay, because in the third case where n is equal to integer, then the y2 is not solution of the Bessel differential equations, that we considered in the last lecture, that we discussed in the last lectures. Okay, so if these things we consider, that is give the solution of this Bessel differential equations, that is yn is equal to jn into dx by jn square into x, like this. Okay, so this function is called Bessel functions of the second kind of the order n's. Okay, now let's discuss one example on these topics. Okay, so this is also called okay, this is these things Bessel of the second kind of the order n's. Okay, so let's discuss one example. J half in function of x is equal to under root 2 by pi x into sin x. Okay, this is a given examples. So we know the first I am consider the left hand side, that is j in x. Okay, in the general expressions. Okay, here is a given n is a half. Okay, but I am going to write the one series or Bessel functions. Okay, j in x is equal to, we know it is x power n divided by 2 power n gamma n plus 1. Okay, into 1 minus x square divided by 2 into 2 n plus 1 plus x power 4 divided by 2 into 2 square into 4 n plus 1 into n plus 2 n minus so on. Okay, this is a series for these functions. Okay, this is x power n and this is 2 power n. So here this n is given, that is half. Okay, so if I write I replace this half n with the half. Okay, so n is equal to half. Okay, so now I am going to just replace this n with the half. So it series becomes j half the function of x is equal to x power half divided by 2 power half gamma half plus 1. Okay, and into 1 minus x square divided by 2 into 4. So it is 4 half plus 1 plus x power 4 divided by 2 into 2 power 2 into 4 half plus 1 into half plus 2 and so on. Okay, so this is in the under root, this 2 is also in under root, and from this is a 3 by 2. This is if we add half plus 1, so it is 3 by 2, and this is a 5 by 2. Okay, so just write here j half under root x divided by under root 2 and gamma. Okay, this is in the under root and this is a gamma, so it is 3 by 2. Okay, into 1 minus x square divided by 4 into 3 by 2 plus x power 4 divided by 2 into 2 square into 4 3 by 2 into 5 by 2 and so on. Okay, so this gamma we can write, if we take out the half is outside, so this thing is under root x divided by under root 2 into half, so this gamma half. Okay, this is expression for the gamma, and for this if I take out the 1 by x is outside to this bracket, so here x, okay, minus here is x cube divided by, now these things if I simplify, so it is 2 into 2, 2 into 3, so it is 6, and this 6 know that we know that it is 3 factorials. Okay, and plus if I simplify this denominator, so here is a 120 and this 120 is equal to 5 factorial. Okay, so it is x power 4 divided by 5 factorial and so on. So here x power half and this is power ones. Okay, so half minus 1, if we can write like this, x power half minus 1, so it is equal to x power minus half, and these things we can write 1 by under root x. Okay, same for here, so here is 2 by under root 2. Okay, so these things we can write 2 power 1 minus half, and this is 2 power half is equal to under root 2. Okay, so just I am going to write this under root 2 here and the 1 by under root x here. Okay, so it is equal to for this 2, so it is under root 2 divided by under root x, and this gamma 1 by 2 is equal to under root pi. Okay, this is relations. Okay, I am using here, so it is under root pi, okay, and into x minus x cube by 3 factorial plus x 4, sorry, here is a 5 factorial, sorry. Okay, because we are taking out the commons, that is 1 by x. Okay, so this 5 power become 5. Okay, so this is series of the sin x, so we can write it is sin x. Okay, and this thing is equal to 2 by pi into x into sin x. Okay, so this is equal to what we are having, j half the function of x. Okay, so this relations we prove here. Okay, so let's stop here, we will discuss in the next lecture.